Hey YouTube, welcome back. Today I'm starting a new thing, which will
Hey
be,
YouTube.
which will be that I will make a stream to talk about the overview of NestJS. I will talk about the controllers, providers, modules, middleware, exceptions, filters, pipes, guard, and interceptors, and the customer decorators. This one it will take time. It will be like 5-6 hours long streams because it will be in details. So let's just start this one and let's see if it will be a good idea to make such a long stream like that. So let's just start first thing first. We are right now in empty directory. Everything is empty here. We start to first talk about NestJS. So in this stream, we try to build a CRUD application with features that cover like a lot of the ground in NestJS. So let's start to talk about the setup first. Let's open my terminal and let's just delete everything here. And inside my terminal, first you need to install the NestJS CLI. You do like sudo and you have this command line. You'll find everything in the documentation. It will be quite good to see in the documentation. And after that, you just type enter. I will not do this because I already have installed NestJS. So after that, you want to create a new project. So I'll say nest new. I will call it let's call it demo. And I won't make it in npm, and I have my demo. It will take time. After that, yeah, everything looks great. So let's open the demo, and you will see here we have the structure. Let's focus on the source. We have the controllers, and we have the controller spec, and we have the controllers, the actual controllers. This one is for testing. This one for the actual controllers, and this one the modules, and we have the services. So the controllers, it's just a basic controller with a single route. Let me just delete this, and I guess it's my font size is good right now, or it will need to be bigger. I guess it's good as it is. If you think it's need to be bigger, just feel free to tell me about it. And yeah. So also, if you have any questions, just feel free to ask the question in the chat. I don't know if you can see the chat. Okay, so we have right now the controller spec.ts, and this one is a unit test for the controller. And we have the app.module.ts, which will be app.module.ts, this one, which will be the root module of the application. And we have the service, which will be a basic service with a single method. And we have main.ts. And this is the entry file of the application, which uses the core functions, the NestJS factory, this one, to create a NestJS application. So in the main.ts, the main.ts includes a async function with the bootstrap, called bootstrap, that bootstrap our application. So to create a NestJS application instance, we use the Nest Factory class. The Nest Factory exposes a few static methods that allow creating an application instance. And we have the create method here, and the create hello Hasipul Hassan, hello. And And yeah, and the create method returns an application object which fulfills the NestJS application interface. This object provides a set of methods which are described in oncoming. I'll describe them, but just it takes time. So and right now I guess we start with a controller. Let's talk about the controller. So we know right now in the main.ts we have this was just to bootstrapping our application. We use the next factory to create an instance of our application, and right now we will try to look to the controller. And the controller are responsible for handling incoming requests and returning responses to the client. So a controller, like you can think about it like, let's go to the controller here. Yeah, I'm in control. So you can think about it. You can think about like that. We have the client, and the client sends the request to a controller, and the controller. Oh, no. And the controller will responsible to connect to the service or do something and send the request back to the client. So the controller are responsible for handling incoming requests and returning response to the client. This is the only purpose of the client, of the controller. So a controller's purpose is to receive specific requests for the application, and the routing mechanism controls which controller receives which request frequently. Each controller has more than one route, and different routes can perform different actions. So in order to create a basic controller, we use classes and decorators. Decorators associated classes with required metadata and enable NestJS to create routing map, things like that. So let's just try to create our own controller. So let's go into the source and create a folder. I will call it cats, and inside the cats I will create a cats controller. I will call it cats controller .ts, and I will try to create a basic routing here. So I'll say import the controller. Wait a minute, let me do it like that. Controller from NestJS, and also I will get to, I guess I need to do the get, and yeah, I need to get. So let's create the decorator. I'll say controller, and I will make it, the controller should be for cats, and I will export class. It will be a controller, and I will say I'll create get. Yeah, okay, this is fine example. It's not real world though, but it just fine example. So here in this example, in the following example, we will use a controller decorator, this one, which is required to define a basic controller. We will specify an optional route path prefix of cats. So we have, this is the optional route of the cats. Using a path prefix in a controller, decorators allows us to easily group a set of related routes and minimize repetitive code. For example, we may choose to group a set of routes that manage interactions with a cat entity under the route cats, for example. In that case, we would specify the path prefix cats in the control decorator, so we don't have to repeat that portion of path for each route in the file. So okay, so let's talk about the get. What is the get? So the get, it's a HTTP request method decorator before the find all method tells NestJS to create handler for specific endpoints for HTTP request. the endpoint corresponds to HTTP request method get. In this case, we respond to get methods or to get requests, and the route path. What is the route path? So example, what is the route path? So the route path for handle is determined by the concatenating the optional prefix declarator for the controller. So any path specified in the methods decorators. So since we have declared a prefix for every route, which will be cats. Which will be cats, and haven't added any path information in the decorator, the NestJS will map, like if we have any get requests that talks to cats, for example, any get requests that go to cats, NestJS will directly send it to it, because we haven't add anything here. So if we add something, like if get cats like a breed, for example, in order to hit this method or this request, we have to get cats / breed, for example. So yeah. So we have right now in this example, when a get request is made to this endpoint, NestJS route the request to our user defined, which is find all method. Note that the method name we choose here is completely arbitrary. Like you can use whatever name you want. Like you can make find all, or put some else, like, or find my cats. You can choose whatever name you want for the method, but it's better to do in the find all, because it's because it's just like it's in the way to find all, like most of the developers will work in this way. So it's I would say that it's best practices, but that doesn't mean that you cannot change the name as much as you want. Just feel free to communicate with your teammates in the best naming for the methods that all of you will be comfortable with. So in our example, we said that when a get request is made to the endpoint, NestJS route the request to our user-defined find all method. Note that the method name, as we said, that is completely arbitrary for you, so NestJS doesn't care to it. And this method will return 200 status code and associated response, which in this case is just a string. Why does this happen? Let's just explain what, because it feels like magic. So we have two ways to handle the requests. We have the standard way, which is the quite recommended one, which will be like using this built-in method, which is the get. When request handler returns like a JavaScript object or array, it will automatically be serialized to JSON when it returns JavaScript primitive types like string, numbers, and boolean. However, Nest will send just the value without attempting to serialize it. This makes response handling simple. Just return the value and Nest takes care of the rest for you. Furthermore, we could talk about this one. You can use like HTTP code, etc. And we will talk about this one in just be aware with me. So we can use the library specific Express.js, the OG way, which can be injected using like the res and the rec and stuff like that. So let's just take an example for this one. So we let's import the res from Express, and let's just import the rec. So in order to do with the rec and res, so we have find all. It will be let me delete this one. Oh no, let me copy this one and import here. Yeah, okay. So in this one we use the request object, and handlers often need access to the request details. Like NestJS provide access to the request object on the underlying platform of by Express. We can access the request object by instructing Nest to inject by adding the rec decorator to the handler signature for you guys. So here, as you can see right now, we can use the rec, and instead of using the old way, if you are more comfortable using the rec. I want to talk about some of the, like, the request object represents the HTTP request, has properties for request queries, strings, parameters, HT headers, etc. All of that objects that we use when we deal with NestJS. Let's just try to talk about them here. So first we have, let me do it like that. What is this? No, thank you. I love Copilot, by the way. Copilot, it's really good. So let's just say, like, we have the request and or the rec, which is with the rec decorator. This is responsible. This is equals to the rec object in Express. We have the response, and the rest is equals also to response in NestJS. We have nest, and I guess it should be all of them have the operator here. All of them should be decorator. Okay, and this is responsible for next. Yeah, we have session, and this one is responsible for rec.session. We have, I guess, the param.key, and this one also to rec.params, and it equals rec.params. We have the body as well. Let's see the body. Yeah, we have the body, and the body is for rec.body or rec.body.key, the same. And we have the query, and the query, let's make it simpler for us. And we have tool equals rec.query, and we have the headers. The headers, and the headers will equals rec.headers or rec.headers name if you have the name of it. We have the IP, which is responsible for, short for the IP address. We have the host name, which is rec.host, and we try to use all of these. Okay. So let's talk about resources. So right now we talked about the request object and what we have here, and we have all of these things in the request object. We try to create our first method, and right now let's just try to talk about the resources. So we defined an endpoint, which is to fetch the cat's resources, which is the get route. We will typically also want to provide an endpoint that creates the new record for example, post request to create a new cat if we wanted to create a new cat. So how we do that? So let me just drink my my coffee. I love coffee. I really love coffee. So let's start here, and let's just make a post, and I will say we have the post here. I will say like okay, I didn't import the post. I will say it will be create, and yeah, and I will expect it to return string, and I will return this, the action adds a new cat, for example. So in this one right now we have two methods. Let's say that it's basically that simple. Like, the good thing about NestJS, it's really simple. It's really simple. There is no complications when it comes to NestJS and how the way to work with it. Let's put this down so we have a good way to, a big way to just see ourselves. So let's talk about the here, as you can see right now, we finished most of it. So let's just talk about the route with wildcards, because I guess some of you doesn't know that we could do that, but like we can do it. So basically we can do like AB, for example, AB star CD, which is basically this means, oh no, which basically this means that you can do like A, B, C, D, or A, B like that. You can do, or like any character between A, B and C, D, like A, B, anything or nothing between them. Of course, there are some things that are not allowed. I guess this isn't, that question mark is not allowed. The plus is not allowed. Maybe, I guess other things are not allowed, but mostly you can do this with the routing. Okay, so let's just delete all of that, and let's talk about the status code. So, as mentioned, the response status code is always 200 by default. Except for the post request, we have 201, and we can easily change this behavior by adding the HTTP code. So let's say that I want to make the status code to be 204. So I will let me copy this. Why? Okay, I don't know what's going on, but let's just say that at HTTP code, and I want to make 204. And let me delete all of that, so we only focus on the code that we're writing. So okay, so as you can see right now, we have the response right now, it's 204. We change it into instead of be 201. So this is how to use the status code. So if we want to use the headers, let me delete the status code to specify specific header, like custom header. Like you can either use a header decorator or library specific res.header if you want. So if you want to use the header decorator, let me delete this, and let me delete this. So if you want to use the header decorator, you will basically use like everything starts with decorator, and we just type header, for example, and maybe you want to make like a cache control. No. For example, cache control is none. So but this way, like you just import the header from NestJS. Let me delete this because it's an error. Let's talk about if you want to do like some redirection. So to redirect a response to a specific URL, you can either use the redirect decorator or library specific response, which is res.redirect directly if you want. So let's say that I'm here in the get one, and I want to just redirect it to somewhere else. So we can use the here redirect. Yeah, for example, HTTP NestJS and with a response 301, for example. Also you can return values. You can return values return values. So basically, return values will override any arguments passed to the redirect decorator. Like, yeah, this is the thing that you should put in mind. So let's talk about the route parameters, because they are a big thing. So let's say that I want to find one cat. We have a method that creates cat. We have methods that find all cats. Right now we want to define the methods to get one cat and one cat only. So how we can do this one? So we can do just get. Let's do like we have the get operator, and we have ID, and it will be find one. Yeah, it's something like that. Okay. Just you can see that we only return strings, and we try to in the future to make a proper returning an improper data, but we're just trying to start easy, and after that we just scale it up if we want. So right now we created a method. We used a route parameter to get one cat. So the routes with the static path won't work when you need to accept, like for example, dynamic data. So we want to have dynamic data, which is dynamic data. For example, we want to have like a get. For example, we want to have like get cat /1. So we have to use a dynamic data. We have to use it like that. So because of that, it's a good idea to handle route parameters, and this is the way to handle it. So let's continue to talk about the subdomain routing. So if we wanted to do subdomain routing, like for example, the control decorator can take a host option to require the HTTP host of the incoming request matches some specific value. So for example, if we have the controllers here, you can write, for example, let's just go and give dummy example here. So I could just have like an object. I could just say that, okay, I will have a host. It should be it should be like admin.example.com, and I'll maybe like support class. It will be admin's controller, and for example get, and we return just admin. That's it. Nothing too fancy. So here, as you can see, like we can use the host name if you want to return something to the user. It's similar to a route in the path option. Can use token to capture the dynamic value of the position. If you want, like example host admin, you can just make a host something like that, just to take whatever we have. As you prefer. So the host parameter token is in the controller decorator example. As you can see here, demonstrate this usage. So let's talk about the let's delete this one. Let's talk about the scopes. Like for people coming from different programming languages backgrounds, it might be unexpected to learn that in NestJS almost everything is shared across incoming requests. So we NestJS have a connection pool to the database, singleton services with global state, etc. Remember that Node.js doesn't follow the request response multi-thread stateless model, in which every request is processed by separated thread. Hence, using a singleton instance is fully safe for the application. However, there are edge cases when request-based lifetime of the controller may be desired behavior. For instance, per request caching in GraphQL application, request tracking, or multi-tendency. We will learn about this more in the future. I guess I will not be able to do this in today's video. Today, I just will be overview, and this one is pretty something. It's related to what? to overview. So basically, and the other thing, it will be quite something related to GraphQL. So GraphQL, I guess we will try to discuss GraphQL in 2-3 days from now. So let's talk about asynchronous. So if we want to return something asynchronous, because we love modern JavaScript and we know that data extraction is mostly asynchronous. So if you are getting something, it's mostly asynchronous. You use asynchronous things. So that's why NestJS works well async function. So let's say that we have the find all right now. We don't want to return we don't want to return just a string. I want to return an array. So for example, I'll return here an array. And because it should return a string, it will be array here, and everything looks fine. However, it might be a promise. It might take time. So let's just define an async and say that it will be a promise that should return an array, and this array could include any So every async function has to return a promise. This means that you can return a different value where that NestJS would be able to resolve by itself. So as you can see here from this example, this code is fully valid, but furthermore, NestJS route handlers are even more powerful by being able to return observable streams. Like for example, you can delete this one and use observable and just return any give me a minute here. Let's just a quick fix this one. Yeah. Okay. Anyway, so you can use observable stream if you want, and let's go back with the promise that we all know and love. Let's talk about the request payload, because in the example here in the post request, and the example here in the post request, example, route handler didn't expect any client params. So we need to fix this by adding a body decorator. So first, I guess because we use the TypeScript, we need to determine the DTO, which is the data transfer object schema. A DTO is an object that defines how the data will be sent over the network. We could determine the DTO schema by using TypeScript interface or simple classes. Interestingly, we recommend using classes here. So let's just talk about why classes and not interfaces, because you can use interfaces, but it's important to use classes because classes are JavaScript E6, and therefore they are preserved as a real entities in the compiled JavaScript. So on the other hand, since TypeScript interfaces are removed during the transpilation, NestJS can't refer to them at runtime. So basically, this is important because features such as pipes enables additional possibilities when they have access to the meta type of the variable runtime. So let's try to create a CTO here. So I will create a folder. I will call it DTO, and I will create /cat.dto.ts, and I will export this class here. So it will be create DTO here, and I will try to import this class. First I will add the body, create. Let's remove the header. We don't need the header anymore. So I'll say create body. The body is important from here. I do not need the header right now. And the body is will have create dt create cat, and I guess, yeah, and I need to make it async as well, because it should. Let's not care about what we are returning here. Enable to resolve signature of parameter decorator when sorry, I forgot to put that. So as you can see here, this is the way that we can add. We created the DTO. We use the body. So let's talk about how we handle the the errors, how we handle the errors. So we will try to talk about, there will be a specific stream that talks how to handle the errors. It will be dedicated to how to handle the errors. So let's try to see the full example. And let's see here. So let's see right now. Right now we have the get find one. We maybe need to put. So if I want to make put, so I'll just use the put parameters. And put will take ID, and I will say it will be, I'll call it update. Okay, it's string. It will do the same here. Maybe I have to add a delete. And but I guess the update, it should add something to the params. So I will add the params. I guess I need to add the params. I need to add the delete. I need to add the query. So in the find one here, I will use the query, for example. So it will be the query. Let's just see if we can do it here. Yeah, the query. Let's add the query. In the get one, no, the get one it will be the params. In the get all, we'll use the query. In the get all, we'll use the query. In this one, we'll use the params. And we have the put, and let's just add the delete. All of them are quite dummy method right now. When we try to introduce this, the providers, it will be way more different. It will be really way more different. So let's just have the delete. And let's say call it remove. It will I don't expect that it will return anything. I just the remove, I'll just return this action removes the cats, and that's it. So I guess that's it when it comes to the controllers. And I guess it will be good to it will be good if we just get up and running it. So if we of course if we're running, nothing will happen because there is nothing to be run. But let's just try to say, okay, we have a controller, we add the controller. What we should do next? We should go to the app.module with app.modules here. And inside this app.modules, like with the controller that we did defined, still doesn't NestJS still doesn't know about the cats controller that we created. So we need to import it. So what we should do, we should add it here, and we should add it into the controllers. Let's delete this one. Right now we should have a service that is quite close. Let's just delete all of that, and we only have the control right now. And let's just delete this one. We doesn't need them. And let's just delete the app controller here because we doesn't need it also. And let's just delete the app service because we doesn't need it as well. And let's only have the kits that we work with. So let me just drink coffee. Okay, so right now we have our controller, and we did add our controller to the module. So right now NestJS know about it. So let's talk about the providers, which all the providers are the fundamental concept in NestJS. Like many of the basic Nest classes may be treated as providers, like services, repositories, factories, helpers, and so on. The main idea of the behavior of the provider is that it can be injected as dependency. This means objects can create various relationships with each other, and the function of wiring up these objects can largely be delegated to the NestJS runtime system. So if we want to create the service, because as you can see that the service is in the cats controller, the controllers should handle HTTP requests and delegate more complex tasks to providers. The providers are plain JavaScript classes that are declared as providers in the module. In the services, let's just try to create a service. So we have the cats here. So if we have the cats, we have the service. Let's just create a service, and I will call it cats.service.ts. Cats.service.ts. Okay. Of course, in real world, you will need to maybe create. It will not be one file that handle everything. It will be more than that. Let's see right now what should we do. So let's start with creating the cats. We need to first use something we use the injectable from NestJS, and in and we use something we call interface. Of course, we don't have this interface yet because there's no such as interfaces. So let's just create this interface. New folder, interface, and we should create cats.interface.ts. And we should export the interface of the cat. Okay, so let's talk about this one. So let's just try to create a dummy example, and let's see what the injections do and what is the interface imported for. So let's create everything starts with the injectable. Just we call the injectable decorator to create a new provider or a new service. So we'll export class cat service. Okay, we will make we found reference to public code in recent resolution source Copilot. What is this? Okay, thank you Copilot. GitHub Copilot is just really brilliant. Just I'm not sponsored by them, but hopefully I am one day. But they are really brilliant. So I have here a private just read only, and to make it quite safe, and I create this push. It will be I'll push the cat I get from as a parameter, and find all. I find all, and I have the cat as well, and I just have these two parameters here, two methods here. So our cat service right now is a basic class with one property and two methods. The only new features here is the injectable decorator. The injectable decorator attaches metadata which declares that cat service is a class that can be managed by NestJS IOC container. By the way, this example also use the cat interface that we talked about, and I guess the interface is something that just attached to TypeScript. It's not something new. So the only thing is new, it will be the injectable. So let's try to add. Right now we created two services, and right now let's go to the controller and let's try to add these services to the controller. So I will create. I have the create. We have the create CTO here, and we have the cat. We should implement the cat interface. So let's input it here, and I guess we should create add the cat service, and let's just in the cats controller we should create a constructor. So the constructor, it will be private read only. It will be a reference to the cat service, So if we want to create a new if you want to create a new body, I will call this dot this dot create service dot create, and we know it's just a create because in the cat service we have call it create, and get and find all. Let me just delete these three, so we just only focus on these. And get and find all, we have promise, and the promise, it will not be any anymore, it will be cat, and we return this cats find all, and yeah, that's it. So so basically right now here in our example, let me try to make sure that if I'm doing it right or wrong. Yeah, let's try. So the cat service is injected right now through the class constructor, and you should notice that the use of the private syntax, this shorthanded, allows us to both declare and initials the cat service member immediately in the same location. Let's talk about the dependency injection. So NestJS is it's built around the strong design pattern commonly known as dependency injection. So we recommend reading a lot of articles that it's in Angular, because in NestJS it's quite close to how Angular work. It's more than that, and I will create a video to talks about how to understand the dependency injection, because it's really important for us to know how to handle that. So let's just leave it right now. It's built on it's built on dependency injection. What should it will work? We will do video dedicated to talk about only the dependency injection. So in NestJS, thanks to TypeScript capabilities, it's extremely easy to manage dependencies because they are resolved just by type. So in this example that you can see here, NestJS will resolve the cat service by creating and returning an instance of the cat service, or in the normal case of the singleton, returning the existence instance if it has already been requested elsewhere. This dependency is resolved by passed to the controller's constructor or assigned to the indicated property. So let's talk about the scopes again. So providers normally have lifetime scope synchronized with the application lifecycle. When the application is bootstrapped, every dependency must be resolved, and therefore every provider has to be initiated similarly. When the application shuts down, each provider will be destroyed. However, there are ways to make provider lifetime request scope as well. We can talk about this one in other video. If we want to talk about the customer providers, like NestJS has built-in inversion of control, which is IOC container that resolve relationships between providers. This feature underlying the dependency injection feature described that we talk about described. I guess we just described before. Like, just feel free to just go back with the videos, but it's in fact far more powerful than what we described so far. And we will try to talk about this one in the future as well, because NestJS is just a big one. It feels like magic, but it's just a big framework that we need to learn a lot about how it works. Because in my opinion, the way that you'll be great in a specific framework is to know how this framework works, not how to use it, just to know not only how to use it. Of course, you need to know how to use it, and it's a great start to know how to use it. However, you need to know how this framework works. Let's talk about you can do like optional providers. Like occasionally you might have dependency which not necessarily have to be resolved. For instance, your class may depend on a configuration object, but if none is passed, the default values should be used. In such a case, the dependency becomes optional because lack of the configurations provider, for example. We can talk about the property based injection. Basically, the technique we have used so far is called constructor based injection. You can use a property based injection, like if you, I guess if you know how, it's maybe it will be quite easier to understand. But we'll talk about this one also in the future. Let's talk about the provider registration. So we have the provider, and we have the service. We have the service right now, and we add an instance of it here. But still, now we need to define a provider into the cat service. So, and we have to consume of that service. It should be the cat's controller. So we need to register the service with NestJS so that it can perform the injection. We do this by editing in our app.module. Let me delete this also. What did I do? How it get big? Why it get that big? I don't like that. What did I do? I did like it get really big. I don't know. I don't know. Anyway. I need to delete this one. Move the trash. Anyway, I guess it's bigger one. It's better for you guys. I don't know. So, like now, let's try to add the provider, the providers here. So I will go to the services. I'll add here, and in the providers, I'll add a provider, and it will be the cat service, and voila, it's done. It's just that easy to add. So it's important to see about how we create our system and how we do the providers, how we do the controllers, to talk about the architecture of our file, because it's important to know, and it's important to follow this one. So if you need me to push this one into GitHub so you can look at it, I will do it for you guys. Just feel free to comment to me and tell me, yeah, just put it there. So let's talk about the modules. We talked about the providers. We did talk about the CAD, the controllers, and I guess we shouldn't talk about the modules. And I guess, guys, we quite halfway through. We have maybe 1, 2, 3, 4, 5, 6 sections more. We finished 3, and we are talking the 4th right now. So we did good. Thank you for listening, and thank you for paying attention. So let's talk about the modules. A module is a class annotated with module decorator. The module decorator provides metadata that NestJS makes use of to organize the application structure. So as you can see, let's look about how this one works. So we have the application model, and inside the application model we have, for example, beneath it we have like users model, module, and module, and for example cats module, and tag and dogs module, and so on. For maybe let's talk users module and orders module, and maybe you have a chat module. And for example, we have some providers, and the providers are maybe like, for example, like feature module 1, feature module 2, feature module 3, and maybe this feature module 1 is connected with the orders models, and connected with the users at the same time, and so on and so forth. So each application has at least one module, which is the root module. Let me just do it like that. Okay, So each application has at least one root module, which it will be this one. And a root module, this root module is starting the point NestJS uses to build the application graph, which is the internal data structure NestJS uses to resolve module and providers relationships and dependencies. While every small applications may theoretically have just the root module, this is not the typical case. So we want to emphasize. Sorry, sometimes I lose word. We want to we want to emphasize that modules are strongly recommended as an effective way to organize your components. Thus, for more applications, the starting architecture will employ multiple modules, each encapsulate closely related to set of capabilities. So the module decorator, this one, the module decorator takes a singleton object whose properties describe the modules. So we have providers, controllers, imports, and exports. So the providers that will be initiated by NestJS injector and may be shared at least across this module and or maybe other modules. Controllers, in the controllers here, as you can see here, the controllers they are a set of controllers defined in the module which have to be initiated. We have imports, and the imports are the list of the imported module that export the providers which are required in this module. We have the exports, and the exports are the subset of the provider that are provided by this module and should be available in other modules which import this module. Like you can use either the provider itself or just its token, which is the private value. The module encapsulate providers by default. This means that it's impossible to inject providers that are neither directly part of the current module nor exported from the imported modules. Thus, you may consider the exported providers from modules as the module's public interface or API. So let's create a feature model. So in the cats, I will create a module and I will call it cats.module.ts. Okay, and the cats controller and the cat services belong to the same application domain. As they are closely related, it makes sense to move them into a feature model. A feature model simply organizes code relevant for specific features, keeping code organized and establishing clear boundaries. This helps us to manage complex and develop with solid principles, especially as this size of the applications or the team grow. And I will make a dedicated video about the solid principles. So let's talk about the cats modules, and I'll try to. It just will be the same one, just modules, the same here, just the same, but it's called cats module. And in this example, in the cats model, we define the cats model in the cats model.ts file and moved everything related to this module into the cats directly. And the last thing that we need to do is to import the module into the imports. So and let's do this one here, cats module. Oh, no. This is right. Sorry, I should put it here. And yeah, it works right now. It works perfectly. Okay, so what is the duration of this one? Oh, it's 1 hour already. Okay. So right now we have, as you can see right now, our structure, it looks quite cleaner right now. So we have the DTO, which we put only the create. We have the interface. We have the cats controller. We have the module, and we have the service. Everything looks fine. So I guess the structures look way more better. And we have the we have shared model. We can use some shared model, like in NestJS modules are singleton by default, and thus you can share the same instance of a provider between multiple modules effortlessly. Like for example, you have like you can export for example, if I want to share it between others, so I'll go to here, I'll put here into the exports. So every model is automatically a shared model. Once created, it can be reused any model. So let's imagine that we want to share an instance of the cats service between several other models. In order to do that, we first need to export cat service provided by adding it to the modules exports array as we show you here. And yeah, so I guess now any module that imports the cat module has access to the cat service and will share the same instance when all other modules that important is as it is. So the modules re-exporting. Let's talk about the module re-exporting. So as seen above, that we can see you here right now, modules can export their internal providers. In addition, they can re-export modules that they import. In this example, so basically we can have import something here, import like other service if we need, like use like a common module, for example. We can talk about the dependency injection, like a module class can inject providers as well. And yeah, we have global modules, like if you have to import the same set of modules every way, it can be quite tedious. Unlike in NestJS, Angular providers are registered in a global scope. Once they defined, they are available every way. NestJS, however, encapsulates providers inside the module scope. You aren't able to use the modules provider elsewhere without the first importing the encapsulating module. So when you want to provide a set of providers which should be available everywhere out of the box, like helpers database connections makes the module quite global. So we can just make it like that, global. And you could use the global from NestJS to make it global. So the global decorator makes the module global scope, and the global modules should be registered only once, generally by the root or the core module in the above. In this example, in the above example here, the cat service provider will be ubiquitous and modeled. The modules that wish to inject to the service will not be need to import the cats model anymore if it have the global decorator. We can have also dynamic modules. So the NestJS model system includes a powerful features we call dynamic modules. This features enables you to to easily create customizable modules that can register and configure and providers dynamically. Dynamic modules are covered extensively. I will cover it extensively in a separated video because it's such a big thing. And yeah, it's just, but you just know they are just there for you, because I just want to make sure this is just an overview. I don't want to dig too deep into some aspects, um aspects here. So also you can also use like a database module, or like root use or something like that. But we will talk about the dynamic modules in details in dedicated videos. So let's talk about the middlewares, I guess. So the middlewares is a function which is called before the route handler, and basically the middleware function has access to the request and the response objects, and use the next middleware function. It just exactly as Express. In function in the application's request response cycle, the next middleware function is commonly denoted by variable named next. So nest middleware are by default equivalent to Express. They are exactly the same as Express. To the following and the description of it will be like, for example, we have the middleware functions perform the tasks. First, we execute the code, makes changes to the request and the response objects, and the request response cycle, call next middleware functions in the stack. If the current middleware function does not end the request response cycle, it must call next to pass control to the next middleware function. Otherwise, the request will be left hanging out. So you immediately you implement custom nest middleware in either function or in a class within the injectable decorator. The class should implement the nest middleware interface, while the function does only have any special requirements. So let's just start here. So I want to create, for example, a logger.ts. It will be a middleware. So let me try to create. So let's create a middleware here, and in the way that I'll have to create a middleware, we create a file. I will call it common, and inside this one I'll maybe create like middleware. Let's call it and inside the middleware I will create a new file. I will call it, for example, logger.ts. Okay, so in this one I'll just try to import two things: the injectable and the nest middleware. If you all quite concerned about the injectable, I will make like dedicated videos only to talk about the injectable, because it's being used everywhere. I guess we need to have the access to the request response and the next function from Express. We start by adding the injectable, and we create a class, and class, it will be logger middleware. We implement NestJS, for example. Yeah, it will be something like that. Yeah, just something that we only cancelled a lot. That we don't have anything to do. So in terms of the dependency injection, so Nest implement middleware fully supports dependency injection. Just as with providers and controllers, they are able to inject dependencies that are available within the same modules as usual, and this done through the constructor. Let's talk about the applying the middleware, how we can apply this middleware. So we have middleware right now. Let me just drink a coffee. So right now I have the middleware. We want to apply it. So I will go to the app.module, and I will import the middleware here, and I will export. In the export here, I will configure this middleware. So I'll just say implements first the class elements. I will implement the middle, so implements NestJS model, and I will configure. In the configure here, I will say the consumer. No. Consumer will be. I should add the middleware consumer of NestJS. It will be this one, and let's see the we will consumer. The consumer here will be apply logger for each cats or for routes cats. So let's talk about this. So in this example, we have set up a logger middleware of the cats route handler that were previously defined inside the cats controller. We may also further restrict a middleware to a particular request methods by passing an object to containing the route path and request method to the for the route methods. So when configuring the middleware in this example below, notice that we import the request method, which is the enum to reference the desired request method. So we only above the 1 hour. I thought it will be only 1 hour long video, but it just takes more. It really takes more. So if you want to make this one only to the get request, for example, like we can do it like that. So it will only be passed to the cats with the method that has to get. So we can just add this middleware to it. So we can do this the same for routes with cards. We can do with everything that we want. But let me just go back to the previous one, which is we apply it to everything that we know. You can exclude routes if you want, like if you don't want to, for example, the logger to exclude all the route. So what you will do, you will have, for example, you have the apply here, and the apply, it will be, if you want to exclude some things, we could use the exclude method. And of course we have the request method. I guess the request method is from command.js. Yeah, you can exclude some routes if you want. You can have functional middleware if you want, instead of having a class middleware. So the functional, like the logger middleware, for example. Let's go here. The logger middleware class we have using is quite simple. So it's no matters to no additional methods and no dependencies. So why can't we just define it as in a simple function? It will be quite easier to define it in simple function. So we can do it like that, which is way more simpler. As you can see, just way more simpler. And inside the app.modules, we use, for example, let's go to the app.modules here. We use, for example, here, where is the consumer? Let me go here and consumer the logger, and we have logger, and that's it. So we can use multiple middlewares, as if you want. We can have like we use with scores, helmet, logger, like as mentioned above. In order to bind multiple middlewares that are expected sequentially, simply provide a comma separated. So you can add the course as a middleware, you can add helmet as a middleware, and so on and so forth. You can have like a global middleware, like if we bind to if we want to bind middlewares to every registered route once, we can use the use middleware in the main.ts. You can do it like that, and this will, but this should be in the scope. If you want to use the logger everywhere, of course you should import the logger if you want to use it. And this is all about the middlewares. Let's talk about the accepting exceptions filters. And I guess right now we officially halfway through. We have maybe the exception filters. We talk about the pipes, the guards, and the interceptors, and the custom decorators. So maybe you have 5 more. We finished 5, and we have 5 more. So that's great. That's great. So let's start talk about the exceptions filter. So Nest comes with a built-in exceptions layer, which is responsible for processing all unhandled exceptions across an application. So when an exceptions is not handled by your application's code, it's caught by this layer. So which then automatically sends appropriated user-friendly response. I cannot focus. Just making a stream, it's not easy. It's really tough. So let's just say out of the box, this action, like for example, we have a client, and the client try to connect with the route handler. We have pipes, and we have filters. So out of the box, this action performed by a built-in global exception filter. So we could handle which handles the exceptions of types like HTTP exceptions and subclasses of it. When an exception is unrecognized, is neither HTTP exceptions nor or a class inherits from HTTP exceptions, the built-in exception filter generates the following. For example, we generate like internal server error, this one, and throwing standard exceptions. Like for example, let's go to the controllers, our cat controller. And let's talk about the find all here. So Nest provides a built-in HTTP exceptions clause exposed from the NestJS common. So we can use it if we want. For typically HTTP REST or GraphQL API-based applications, it's best practice to send standard HTTP response objects when creating error conditions occur. For example, in the cat controller, we have find all methods here. Find all method, which is a get route handler. So let's assume this route handler throws an exceptions for some reasons. To demonstrate this one, we will hard code the follows. So we'll try to throw and let's just delete this one. And let's delete in the async here, and let's add the where does the HTTP status come from? Yeah. So when the client calls this endpoint, the client will get this one. Will get this. It will get forbidden status code for all 3. And so basically the HTTP exceptions constructor takes 2 required argument which determine the response. So we have the response and the status. So this is the response and this is the status. So the response is argument defines the JSON response body, like it can be string or object as you can see. The status are the argument defines in the HTTP code status, like 403 is forbidden, 500 is internal server error, and so on and so forth. By default, the JSON response body contains 2 parameters: status code and the message. The status code defaults to the HTTP status code provided in the status argument. The message is a short description of the HTTP error based on the status. To override just the message portion of the JSON response body, supply a string in the response argument. To override the entire JSON response body, pass an object in the response argument. Nest will serialize the object and return it as JSON response body. The second constructor argument is the status, which is this one, the HTTP status. And the HTTP status should be valid HTTP status code, and best practice is to use the HTTP status from NestJS common. It's an enum imported from NestJS common. There is a third constructor argument optional, which is the options that can be used to provide an error case. This case object is serialized into the response object, but it can be useful for logging purpose, providing value, information about the error caused the HTTP exceptions to throw. So for example, for this one, you can like do like a try and catch. Like let me do it like that. And for example, yeah, it will get an error because the service does not exist on the type controller. Cat server. Yeah. So you can do it like that. So using this example, the response, it will be something like that, because we have the error here with throw, and we have the status, we have the error, and this is the options. So basically we will have this one as a response, and what is the error here? I don't know. And you can create your custom exceptions if you want. So you can create a class for yourself. So in many cases you will not need to write custom exceptions, and you can use built-in NestJS HTTP exceptions, and as described in before. But if you need to create customized exceptions, it's a good practice to create your own exceptions hierarchy, where your custom exceptions inherit from the base HTTP case class. With this approach, Nest will recognize your exceptions and automatically take care of the error response. So let's just try to see how this will work. So let's just try to create like a dummy example here. So I have right now a forbidden exceptions, and I'll just create it. I could just use it anyway. Sorry, I can use it any way I want. So I'll just, if I want to throw, I could just throw it here, throw new forbidden exceptions, and that's it. If I want to do here, so let's talk about the built-in exceptions. We have a lot of different things. We have the bad request exceptions, we have the uninitialized exceptions, we have not found exceptions, and we have the forbidden exceptions, not accepted, conflicts, so on and so forth. You can just check the documentation for all that. I will not go through all of this. You can create the exceptions filters. So while built-in exceptions filter can automatically handle many cases for you, you may want to fully controls over exceptions layers. For example, you may want to add logging or just JSON schema based on some dynamic factors. Exceptions filters are designed for exactly this purpose. They let you control the exact flow of control and the content of the response sent back to the client. So let's create an exceptions here. So I'll create it in the we can create exceptions. Where should we create the exceptions? So anyway, so I'll create exceptions in the common. Let's go to the common here, and I'll create new folder. I'll call it exceptions, and I will call it new file HTTP exception.filter. So in this one we can just create our own exceptions here. So let's say that we import, I guess we will need the exception filter, the catch, the arguments, argument host, we need the HTTP exceptions, and also we need to have access to the we need to have access to the request and the response from Express. So let's export the class. We call HTTP exception filter, and before that I want to add the catch decorator for it, but I would add nothing. No, back. And I have the HTTP exceptional filter, and if to implement exceptions, let's do it like that. Incorrectly implements interface exception filters. It should be exception implements. I don't know. I'll use the catch. So I'll try to catch the exception. Yeah, that's it. Right. That's right. But I would like to make it more easier here. So let's just delete all of that and use it in this way. So let's just try to talk about what's going on here. So first of all, the catch and the catch exception. So this one, it's a decorate binds the requirement metadata to exceptions filter, telling NestJS that this particular filter is looking for exceptions of type HTTP exceptions. So and nothing else. Basically, the catch decorator may take single parameter or comma separated list, and this lets you to set up the filter for several types of exceptions at one case. So let's talk about the arguments host. So let's look at the parameters at the catch method. So the exceptions parameter is the exceptions parameter is the exceptions object currently being processed. The host parameter is an argument host object, and the argument host is a powerful utility object that we will examine furthermore in another video, I guess. But just you should know it is just there. We use it to obtain reference to the request and the response objects that are being passed to the original request handler. So in the controller where the exceptions originates. So in this code example, as you can see here, we have used some helper methods argument of the host. So which is a switch, HTTP, the CTX. We have used tons of things from it. So the reasons for and the reason for this level of abstraction is that the argument hosts functions is in all context. The HTTP server context we're working with now, but also microservices and WebSockets. In the execution context, chapter we will include in executions video. Sorry, we will try to talk about that in details. You can bind the filters, like you can just add like use filters. For example, if we have here in the catch controller, we have the create, we can just use the filter. And this one, you can use that right now. You can find the filter, and right now we use the use filter decorator here, similar to the catch decorator. It can take a singleton filter instance or comma separated list of filter instance, and here we create an instance of the HTTP exceptions filter class in place. Alternatively, we may pass class instead of instance, leaving responsibilities for instance to the framework, and enabling the dependency injection. And in this example, we can just add a new one here. And in this example, the HTTP exception is applied only to a single create route handler, making it method scoped exceptions. Filters can be scoped to the different levels, method scope and of the controller, or resolve gateway controller scope, or global scope. For example, if we want to add it to the full controller, we can just take it from here, and we can add it here to the class, and this one, it will work for the class. If you want to make it a global one, we can go to the main.ts and edit add it like that. For example, we can do it like that in the main.ts, and it will work perfectly. So in the global scope, filters are used across the whole application for every controller and every route handler. In terms of dependency injection, global filters are registered from outside of any modules with use global filters. As in this example above, we can use it also in the modules paste. So you can use like app filter to do it. So you can catch everything, like in order to catch every unhandled exceptions, regardless of the exceptions type, leave the catch decorator parameters list empty if you want to catch everything you want. Which is, let's go to the, sorry, I'm starting to get quite tired because it's just getting too much right now with just 1 hour and a half, but it just, I'm not complaining. So let's talk about the pipes. So a pipe is a class annotated with the injectable decorator, which implements the pipe transform interface. I guess we have to talk about the pipes. It's not easy to talk about the pipes and the guards and the interceptors. Okay, they are too much customs. Okay, let's talk about the guards. Okay, let's talk about the pipes. No, let's just finish the overview, and after that, we could talk about the fundamentals. We can talk about the fundamentals and the instance providers and so on, so forth. So let's talk about the pipes. So we said that a pipe is a class annotated with the injectable decorator, which implements a pipe transform interface. So pipes have two typical use cases: transformation and validation. So in the transformation, we transform input data to desired form, from string to integer, for example. In the validations, we evaluate the input data, and if valid, simply pass it to through unchanged, otherwise through an exceptions. In both cases, pipes are operated of the arguments being processed by a controller route handler. Nest interposes pipe just before a method is invoked, and the pipe receives the arguments desired from the method and operates on them. Any transformation or validations operations takes place at the same time, after which the route handler is invoked with any potential transform arguments. NestJS comes with a number of built-in pipes that can use out of the box. You can also build your own custom pipes, and in this section, we try to build one from scratch. So we have the built-in pipes, which is the validate pipes, parse-in pipes, parse float pipes, or parse pool pipes, parse array pipe, and parse UID pipe, and also we have parse enum and default value, and we have parse flip pipes. So let's just try to build a pipe. So to use pipe, we need to bind an instance of the pipe. Let's go to the cats here. I don't need this one, and let's go to the cats, and let's just try to create methods. I guess I don't need this one also as well. Let's say that the get, and this one get will be get ID. No, let's just let's go back, or really back. Yeah, okay, this sounds good. So let's just create a new method that I will call it get, and it will take an ID, and I'll say async functions param fine. Okay, return we have cats we have no cat servers that find one, so let's create a new one here. So I'll create find one. It will take ID number. Let's say great. So we have it here. So let's say that we wanna use the parse pipe. So to use a pipe, we need to bind an instance of the pipe class to the appropriate context. So in our parse in integer pipe example, we want to associate the pipe with a particular route handler method. So, and we make sure it runs before the method it is called. We would so with the following things. So let's add parse. So for example, just leave the ID here, and the ID should be number. And here we have we will use the pipe parse integer. So this ensures that one of the following two conditions is true. Either the parameter we received in the find_on method is a number as expected in our call to the cat servers that find, or the exception is thrown before the route handler is called. So for example, if you get request, sorry. For example, if you do get request like that, sorry, cats, and it's not a number, we will get an error like that. Code validation failed, numeric string is expected, and we didn't get a numeric string. So for example, it will be something like that. And yeah, so it will be something like that, for example. So the exceptions will prevent the body of the find_one method from executing. And in the example above, we parse pipe, not an instance, leaving the responsibility for the initiation of to the framework and enable dependency injection. As with pipes and guards, we can instead pass an in-place instance passing, which is passing the pipes. We can create custom pipes if we want. And we can go through the schema validations. We can do everything we want, but let's just talk about the custom pipe. So in terms of the custom pipe, you can create like a validation.pipe.ts, so on and so forth, and I'll create a dedicated video only talks about the pipes because it's just a huge thing to talk about. And let's talk about the guards. So basically, a guard is a class associated with the injectable decorator, which implements a can active interface. And for example, we have like the auth guard to handle authentications. You could have the execution context rule authentications. You can have tons of things with the guard, and the same with the interceptions and the custom decorators. In the upcoming videos, we'll try to make a new video to talk about the pipes and guards and interpreters, but in details. I will make a dedicated videos only for pipes, and one video only for guards, and one for only interceptors. And but this one was a quite quick overview through NestJS, what you can do with it, how you can use the things, and so on and so forth. So that's it for today's video, and I hope you like my content. If you like my content, subscribe and hit the notification bell so never miss a video, and see you guys in future problems. And if you like the streams, please tell me so I will do it more. So that's it for this video, and see you in future problem.